Welcome back to our series on preliminary geological fieldwork. In our last video, we covered the initial steps of a site investigation. Today, in part 2, we're diving deeper into the essential equipment, data integrity protocols, and the justification for this entire methodology. Let's gear up and get started. First, let's talk about the tools of the trade. Executing this methodology effectively depends on a standard, cost-effective geological toolkit. These are the non-negotiable items you'll need to maximize both accuracy and efficiency out in the field. The absolute cornerstone is the geology hammer. It's essential for breaking open rock samples. Why? Because this allows us to see the fresh, unweathered surface, revealing the true texture and color of the material, which might be hidden by surface weathering. Next up is the hand lens, typically with about 10 times magnification. This little tool is crucial for the close inspection of mineral grains, their arrangement, and other fine textural details that are simply not visible to the naked eye. It's what helps us move from just seeing a rock to truly understanding its composition. Of course, we need a field notebook and a geological map. These are our primary tools for recording every observation, sketching formations, and documenting our findings in their correct spatial and geological context. Without them, all our work would be lost. Then we have the acid bottle. This is a small, secure bottle containing dilute acid. We use it to conduct the carbonate reactivity test. A drop of acid on a carbonate rock like limestone will fizz, giving us an immediate and positive identification. A small magnet is another surprisingly useful tool. It's used for assessing the magnetic properties of rocks, helping us detect minerals like magnetite, which can be a key indicator in certain geological environments. And finally, a compass. It's absolutely necessary for orienting our observations, taking structural measurements of rock layers, and navigating accurately with our geological map. This comprehensive yet portable toolkit ensures that all necessary data can be captured efficiently. But remember, the data is only valuable if it's recorded with systematic rigor. This brings us to our next critical section, data integrity and sample collection protocol. Rigorous documentation is just as important as the rock identification itself. The following protocol must be strictly followed to ensure that all field data and collected samples are traceable, contextualized, and hold maximum value for any later analysis. First, systematic labeling. Every single sample we collect will be immediately and clearly labeled with a unique identifier. This label must include its precise location, the date of collection, and key field observations. This prevents any mix-ups and ensures we always know where each sample came from. Second is contextual photography. Before removing any sample from its original location, we take photographs to capture it in its untouched context. This preserves crucial environmental and structural information that is completely lost once the sample is collected and put in a bag. Third, GPS coordinate logging. The precise GPS coordinates will be recorded for every significant observation point and every sample location. This ensures all our data can be accurately plotted on maps and integrated into broader spatial datasets, giving us a complete picture of the area. And fourth, comprehensive field notes. We will maintain clear, organized notes throughout the entire fieldwork process. These notes will integrate sketches of geological formations, structural measurements, and our own interpretative comments, linking specific observations to the broader landscape we're studying. This disciplined protocol guarantees the integrity of our findings. It forms the solid basis for creating the reliable geological framework that justifies this entire project. So, let's talk about that justification and the anticipated outcomes. The methodology we've outlined in this series represents a proven, foundational approach in applied geology. It is designed to build a comprehensive understanding of the project site's geological framework from the ground up. This ensures that all subsequent decisions are based on a solid foundation of reliable field data. What are the primary benefits of this approach? First and foremost, high reliability. The systematic combination of visual analysis, physical tests, and chemical checks creates a cross-verified system for accurate field identification. This reduces ambiguity and significantly increases our confidence in the on-site interpretations we make. Next is cost-effectiveness. This methodology relies on simple, durable, and inexpensive tools. It front-loads the analytical process with expert field interpretation. This helps us prevent premature and unfocused laboratory work, which can be significantly more expensive and time-consuming. We're essentially doing the smart work upfront. And finally, efficiency. These techniques are designed for rapid assessment in the field. This allows geologists to build an immediate understanding of the site. It enables us to make informed, real-time decisions about where to focus more detailed investigation and sampling efforts. We can be nimble and adapt our strategy as we learn more about the area. By executing this fieldwork proposal, we will deliver a robust and reliable foundation of data and strategically collected samples. This will enable targeted, effective laboratory analysis later on and will successfully de-risk the next phase of the project, whatever that may be. It's about setting the project up for success from the very beginning. Thank you so much for joining me for this two-part series on preliminary geological fieldwork. I hope you found it informative and engaging. If you have any questions, drop them in the comments below. Don't forget to like this video and subscribe to the channel for more content on applied geology. We'll see you in the next one.